And good morning. Welcome to today's webinar on sUAS and thermal imaging. I'm Matt Schwegler with the Infrared Training Center. Bill Schwan will be joining us here in a moment. Before we start, just a few housekeeping items for those of you that might be new. I do want to mention that we are recording today's presentation. Just briefly want to mention that later here, we'll have this posted to our YouTube channel. We also have a webinar page off of our main website at infraredtraining.com. But my plan is for later this afternoon on our YouTube channel, I'll be posting up the recording of today's presentation here with Bill. If you follow us on Twitter, Facebook, YouTube, LinkedIn, or Instagram, we'll be mentioning what those are coming up. At this point, looks like next week, we're going to do one on FLIR Thermal Studio templates and possibly optical gas imaging for next Friday. We'll have more information on that here very soon. So stay tuned to these channels for those announcements. And I would expect us to be doing at least 2 of these a week for the next several weeks here as we're waiting to return to live training, which is coming back. Our plans here now for May, for infraredtraining.com/schedule. Any dates from May and beyond are still scheduled. If you want to check out those courses there, again, that's for the US and Canada. And for our fellow thermographers based in Europe, the Middle East, or Africa, irtraining.eu is where you can go for more information on those training dates and locations. All right, but we've got on with us here today is ITC's Bill Schwan. He's one of our instructors. He also handles all of our sUAS training classes, and it's great to have him on. And hopefully you can hear me. He's from his home office in Montana. Bill, good morning. How are you?
Good morning, Matt. How are you? How's everyone out there today?
I'm doing well, and it looks like everyone in chat is looking good too. It sounds like we can hear you fine. But thanks for being here. You can go ahead and start if you want to share your PowerPoint presentation. And
sounds great.
Keep an eye out for questions.
Good morning, everyone. Hope everyone's doing well today. Hey, my name is Bill Schwan with the Infrared Training Center. Today, we're going to talk a little bit about the basics of unmanned aerial systems or thermal imaging from the air. So I see there's quite a few of you out there, and I'm glad you're joining us today. Hope everyone's well. Well, we'll get started here today. And remember, we look forward to your questions. The basis of this webinar is just to introduce you to some UAS systems and applications. It's really not a training or certification webinar. Where can we use this technology? Infrared thermal image camera from a drone, types of equipment, different applications, some regulations, and it's just going to be one slide. So no, it's not about FAA 107. And of course, we welcome your questions and answers. So there's a lot of different applications in the market right now for sUAS thermal. Roofing, home inspections, agricultural, solar panels, utility, overhead power, fire, search and rescue, law enforcement. And that's just a brief name of some of the applications. Hey, if you have some applications that you're using out there that are not mentioned here, put it into the chat, send us a question. We'd be happy to hear what those are. So applications have just been going anywhere and everywhere. We've seen everything from oil and gas is one that's not mentioned here that's really becoming popular, and finding gas leaks from the air with a mid-wave camera, and we can discuss that too. Here's a couple of images, both visual and infrared, kind of showing you roof moisture inspections. And basis of roof moisture inspections is called thermal capacitance. Thermal capacitance is the ability of any material to hold energy. Of course, it has to give that energy up eventually, but as that energy is held underneath the membrane on the image on your right there in circle, you can kind of see that it looks different than the rest of the membrane because it's warmer. And here again, you see some different images on thermal imaging. Here's the basis of it. Dry roof is going to be cooler, and as the water warms up during the day, then that water underneath the membrane becomes warmer, of course, than the membrane itself. After the solar load is off the roof, of course, then that thermal energy has to be given up. When it is given up, it's given up to the cool or cold sky. I get a lot of questions on this, a lot of questions about, hey, can I do this in the morning? Can I do this at noon? And of course, the answer is yes, you can do it any time of the day. But the best time of the day to do this is 30 minutes before civil sunset. Of course, unless we have a daytime waiver from the FAA, we're not going to be able to fly that roof after sunset or 30 minutes after civil sunset. Those are the best times to get it, is when the solar load is off the roof. Sometimes that solar load could be off the roof as early as 4 o'clock in the afternoon if we have an adjacent building that's casting a shadow on the roof. So there's a lot of discussion here of when to fly this roof. Again, this is kind of an interesting image here. Emissivity is different with different roof membranes. And I think with roofing, that's we really have to do our homework before we fly that roof. What is the roof membrane that's applied? Is it TPO, thermal polyolefin? Is it built up? Those are two different, totally different types of roofs that will have different emissivity. If you're not familiar with emissivity, you might check out our webinars at infraredtraining.com to give you the basics of emissivity. Emissivity is, real quick here, emissivity is the efficiency by which a material will absorb and emit infrared radiation. So this roof looks like it may have water on it if we look at it in a thermal image, but if we look real close in the visual image, you'll see those white areas are actually roof coatings. Those roof coatings have changed the emissivity of the roof material. Just received a phone call this week that was rather interesting, actually from a couple of people. Hey, I've been doing handheld thermography for years, but everybody's telling me I should really start to exercise, look at overhead and sUAS thermography. What are some of the advantages? Well, just imagine if you had a 1,000,000 square foot roof, and that's not unusual. It would take you weeks, literally, to do that 1,000,000 square foot roof, where if you were a trained pilot and it could fly the survey correctly and with efficiency, you could probably fly that roof within a 10-day period. But again, and there's a lot of factors that go into that, but there's no need to access the roof unless you can identify areas that could need a core sample. And you can usually get the entire roof in one image, which you're not going to do with a handheld camera. So just some thoughts there. Another application that has grown tremendously are solar panel surveys. And there's probably a few of you out there that might be doing it, or maybe there's a few of you that aren't doing solar panels. Solar panel surveys are quite interesting. There's a variety of different solar panels out there. And the important thing about solar panels is you should familiarize yourself with the different types of solar panels. The other challenge, and not necessarily a challenge, but the other thing that we should understand about solar panels is that they're usually mounted at an angle. So if we're flying our craft with our infrared camera at nadir, the challenge is that we're probably going to see more reflections than heated cells. And so we have to take into consideration and understand the angle which the panel is mounted. And of course, if they're articulating or moving, that's important to know. The type of panel, and also we should see about 650 watts per meter squared. And this should be measured before you do it. Industry specialists have told us in solar panels that if we're less than 650 watts per meter squared, we might be able to see some thermal anomalies, but we may not be seeing all the thermal anomalies. So important thing to know and understand in any application are what are the parameters. So again, angle of image acquisition is important. 650 watts per meter squared is important as well. Don't forget, there's a lot of residential buildings out there, not just commercial buildings, that have solar panel applications. One of the applications, again, that's growing quite quickly with utilities, and not only with just utilities, but utilities contracting out to people to fly sUAS electrical overhead. Now, this can be a quite challenging application, but it's not an application that anyone or that you could not do. If you understand thermography, you could see that these applications are and can be flown. Um, One thing you need to understand is that you'll need to work with your local utility or work with the utility to get their permission to fly their assets. And that's common with solar panels as well, and also common with overhead roof. But you need to understand the components that you're going to fly, permission again from the utility to fly those assets, and then understand what those assets service or what they mean. These are some disconnects here. Some of these disconnects, of course, are quite hot. Well, if you look at those, maybe they're not excessively hot, but they're different than the surroundings around them. And they're showing energies that other components are not. So, again, work with the local utility to identify what these items are and also how to look at them. Here we have a pair of transformers overhead. Again, could we look at these from the ground? Yes, we can, but typically these are going to be 90 feet off the ground. If they're 85 to 90 feet off the ground and you're with a handheld on the ground, you're going to have some challenges in getting the right angle in order to see the thermal anomaly. So it's really important. With overhead, this becomes quite simple. I wouldn't call it simple, but I would say you could do this qualitatively or quantitatively. Qualitatively is you're looking at the image that's the in the field of view, and based on your background, knowledge, and experience, you're going to make a determination on whether that item needs further evaluation. And again, this might be something that is out of your uh, knowledge level. So incorporate the use of your utility or someone with the proper knowledge. Quantitatively becomes a challenge as well. sUAS cameras are not, can measure quantitatively, but there's a lot of variables. And you'd learn about these variables by taking a level 1 sUAS thermography course. We spend at least 2 days on the science, the measuring, the challenges with measuring, and how to address them. We just don't have the time today to address all those questions or those challenges. Um, but the level 1 sUAS class is where you'd learn all about the correct way to measure from the air and the variables with it. Kind of an interesting image here that was obtained. The question is the thermal anomaly energized? And again, if you want to chat us up there and let us know what your thoughts are, that's great. But kind of do your own evaluation here. And I'm going to share something with you here a little bit. This is not an energized component. If you see the clevis ball in the center of the screen, of course, this is in white hot. You're going to see that the ball is quite hot. And the ball on the image is hot because of mechanical stress. So mechanical stress can also cause things to heat up. As we put tension on the line, the molecules start to vibrate, creating their own energy. And of course, aluminum, which is what this would be, would contract and expand different times of the day, showing mechanical stress. So kind of a different image that we wouldn't anticipate. Again, would you see this from the ground? And the answer is maybe, maybe not. But flying this from the air gives you a total different visual perspective for analysis and inspection. So sUAS can be quite valuable in those situations. Building surveys. This is an application that we're hearing and seeing more and more about. Everything from building surveys during phase construction, using both visual and infrared to determine moisture intrusion, leakages, have become very, very popular. Multi-story structures, such as the one you see on your screen, can give us a lot of different information or challenges with a handheld. How do we evaluate the exterior cladding on the 13th floor? It can be quite challenging with a handheld, yet with an sUAS camera on a craft. It gives us a different perspective and better data. Here's a residential structure, and as a residential structure on the second floor, the items you see in the box there are actually areas that are not insulated. So, or have a insulation deficiency. It's pretty interesting. This was taken with a 640 by 512 camera with a 13 millimeter lens. 640 by 512, and we'll talk a little bit here about resolution in a few minutes. But if you look closely, you can actually see the nailing patterns of where the cladding was attached and where the siding might be attached to the structure. So you see the little dots there in this image. It's pretty interesting that the camera can visualize that for you qualitatively. Commercial block wall construction. This is, again, a very interesting application. Maybe some of you have seen or done this inspection. But what you see where the white lines are at the left side of the screen, the horizontal line is identifying a vertical grout line. So when they build a block wall, the engineer is going to designate that every so many feet, we're going to have rebar and we're going to fill that cell in the block with concrete. On large commercial structures and high commercial structures, thermography can help us identify which cells are filled with grout and which cells may be incomplete. So we have vertical and horizontal grout lines here. Of course, similar to roofing, the cells that have the grout in them are going to absorb solar load differently because they're more dense. When they're more dense, they're going to absorb more load. So when the solar load comes off of them, they're going to hold that solar load longer. So this has become a pretty good application as well, and it can be performed from the air. Another visual image from a sUAS, and this is kind of a moisture intrusion challenge on the peak of a roof. Again, one of those images that you would not be able to get from the ground. So this is faster, easier, and again, a different viewpoint, field of view that you'll get from the ground for analysis and collection of data. It's interesting to note here, you can also see the rafters, the roof truss rafters in this image. This is not a metal roof. This is a composition roof. So 640 by 512, again, 13 millimeter camera. Agricultural is growing very, very quickly. When we talk about agriculture, this is very wide span. Everything from looking for livestock to identifying livestock that may be warmer than other livestock. Again, qualitatively, this is just giving you a perspective that, hey, we might check out this animal and see why it would be warmer than the other animals. Doesn't we would just want to make sure that we're not trying to tell you that we can diagnose anything, because we can't. With thermography, we can just simply see that this animal is hotter than another animal. So the other parts about agriculture, I'll just back up here, is we've had a lot of inquiries, and I've seen a lot of people in courses that are identifying the health of plants based on the temperature of that plant. And they're doing it with a 640 by 512, 25 millimeter Zenmuse XT2 So an X-T2 camera with a 25 millimeter lens. Of course, the 25 millimeter lens is very telephoto, so they want to be as close as they can, but they don't want to cool the plant artificially with propeller wash. So is the field overwatered, underwatered? There's a lot of different applications in agricultural, along with near infrared. So if you have any questions, give us a call or chat us up. One of the things we'd like to take a little bit of time here to talk about is resolution. Resolution is really important in thermography. And it's important because the more pixels we can put on the object of interest, the better the image looks. Just like a RGB camera, the higher the pixels, the better it looks. Only with infrared, every pixel contains a temperature if it's a radiometric camera. So it's really important to understand resolution. Can I put all the pixels on this sketch of a house? And the answer is, of course not. That's pretty hard to do. Resolution effects, are you capturing all the thermal anomalies? And the answer is no, you never capture all the thermal anomalies. I'm a real fan when I fly a craft or when I take a handheld image, is I take more images than probably anybody else out there. I'm not uncommon for me to take 25 images of one object. I take the images from different AGLs, from different angles. By taking them from different angles, by taking them from different AGLs, you're going to get a different field of view and a different perspective. That's just going to help you in analyzing that data and giving you more power to provide your client with better results. I get this question a lot. A lot of people call me and say, so what really is the difference between a 160 by 120 Mavic Enterprise or a FLIR X-T2 640 by 512 13 millimeter lens? Of course, there's a lot of Zenmuse XTs out there, 640 by 512, 13 millimeter. But these two images really show you the difference. And one of the differences, if you look real close, you're going to see the vehicle. And then if you look real close at the front door, you can see definite changes in detail by the 3 panels of glass in the entry doorway. So 160 by 120 was basically designed for search and rescue and law enforcement. Resolution really wasn't designed as an inspection resolution. Although if that's what we have to work with, that's what we'll work with. But I thought by putting these two images in here, you might be able to see the two differences between the two different resolutions rather than just talk about them. Hopefully that helps. Instantaneous field of view is what one pixel can see. MRAD, or milliradians, determines what the field of view would be on the roof deck or on the ground. How much can I really see? We go into this in greater detail in the Level 1 sUAS course. 1.308 milliradians is, of course, going to be narrower than 2.519. So 1.308 is maybe 13 millimeter, depending on the resolution, and 2.519 might be 9 millimeter lens. Choices of lenses are very important. So again, another phone call that I get a lot of from a lot of folks is, which one is good for me? And it all goes back to what's your applications, not only today, but what are your applications going to be in the future? Look down the road 5 years, because you may choose a 25 millimeter lens, which is very telephoto, and that would not give you a wide enough field of view or limit your field of view if you're doing a 1 million square foot roof membrane. So look into the future a few years and kind of predict. I think the most popular utility lens for the camera is 13 millimeter, a little mix of wide angle and telephoto. So that's been probably the most utility. Angle of view, or Angle of image acquisition is very important. Here on the right in the infrared image, you see three images. At the very bottom, AR1, you're going to see the reflections of some trees in the background behind you. AR2 is going to capture some clouds and a portion of the sky, and AR3 is going to capture the entirety of the sky. So these three different viewpoints, how you capture this is going to be very important. Another good image here. Here we have some roofers standing on the roof of the bottom right-hand corner, and you can see that's very reflective. I've had people tell me that the upper image, the grayscale image, is actually a wet roof, and actually it's not. This is called angle of image acquisition. The lower the angle, generally below 60 degrees to our object of interest, the lower the emissivity begins to drop and reflectivity increases. So these images are great images to show the impact of the angle of image acquisition. Just a quick question here. The methodology from an sUAS camera is different than from a handheld. How is it different? Well, it's different in many ways. Distance to the object of interest is usually greater. And if I could just spend just a quick minute here on distance. Typically what I see when I visit with pilots is we're flying the craft and the camera too high and too fast for good data collection. Fly lower at a safe AGL to the object of interest and make sure that you watch that angle of image acquisition. Again, no greater than 60 degrees to the angle or to the objective, or your emissivity will be off and you'll see more reflections. Greater environmental impacts. What's the wind speed? Of course, we know wind speed affects our craft, but how does it affect the component? Well, naturally, it's going to cool the component. How about solar loading? Well, under solar loading, we have two things: solar absorption and solar reflection. Depending on the component, depending on the makeup of the component, it may absorb solar energy or it may reflect it, like a TPO roof. Humidity, that also affects our image and thermography. Again, to fully understand how to fly the craft and to obtain the best imagery possible, we suggest that you would attend a level 1 sUAS course, understand all the science behind these cameras. And these cameras are definitely different than the handheld cameras to get the best imagery possible. Hardware, a lot of different hardware here. Sendence controller, you see a Sendence controller here with a crystal sky monitor, DJI M210 or M200. Keep in mind, there's a lot of different crafts out there, and there's a lot of different applications where you could put different cameras on different crafts. So this is just a small snapshot, very small actually, of the time that we have to work with today. Some technical details. Hey, keep in mind that those batteries are only going to give you about 20 to 25 minutes of flight time, depending on your craft, depending on temperature, so your payload, all those things play a factor. I recently did 3 nights or 3 evenings of night flights with an M600. And just as an example, we were getting about 18 to 24 minutes of flight time maximum with a temperature of about 32 to 30 degrees Fahrenheit. So it just gives you some idea. You need to pre-plan this, because if you don't, you won't be able to capture the data that you want to capture. Different cameras, different infrared cameras. Again, a lot of different cameras out there. 2 different resolutions, basic resolutions in the XT2 and in the XT camera, 336 by 256, 30 hertz at 9 hertz, 640 by 512. Again, more pixels, 307,000 pixels on the image, 30 hertz and 9 hertz. So what's the difference in hertz? Hertz is how fast the image refreshes itself. So if we're flying over a large 1,000,000 square foot roof, as an example, we'd want a 30 hertz refresh rate. Keep in mind there may be restrictions on export on 30 hertz, where may not be available on 9. Different lenses, 9, 13 millimeter, 19 millimeter, and 25. 25 being very telephoto, 13 a general utility, and 9 being more wide angle. So all the data here is stored on the SD cards. There's a lot of different cameras still out there, like the FLIR Dual Pro R, and that camera can work as well. Make sure that you understand FAA Part 107. I worked with a gentleman just yesterday who called me up and said, Bill, I need to get a daytime waiver. Of course, the daytime waiver gives you a waiver to fly at night. So daytime waiver is kind of a term that some people don't understand, but there's a lot of challenges that you need to understand. And of course, if you go to FAA.gov, UAV, there's a lot of information there. Don't forget Drone Zone. Drone Zone has a lot of information there as well that can help you get set up for waivers and also airspace authorizations. They're two different things, so you want to educate yourself about those as well. Markets. Where are we going with this? Is this market on the upswing, or are we on the downswing with this market? Well, 3.5 years ago, when we first kind of started the Level 1 sUAS course, everybody kept asking the question, well, should I get into this? Should I not get into this? They had new data, new information here. Services market estimated to be 4.4 billion in just 2019. That was in 2019, and projected to reach 63.6 billion by 2025. So the growth is going to be tremendous. And I think, and I said this 3.5 years ago, I think we're just dipping our toe in the water here. I think we're just getting started in this. So it's a pretty exciting time to be involved in sUAS inspection with thermography. Where can I learn more about sUAS solutions? One of the FLIR partners, a couple of them here, Planet In-House. Cassandra at Planet In-House and Todd Hillhouse are wonderful people who will answer your questions and help you determine what your needs might be. And the other one is Viper Drones. A shout out to Viper Drones. They recently really helped us out in a mission that we were flying for law enforcement. And they primarily, their niche or their expertise is both in long wave and mid wave cameras. They really understand the mid wave camera and how to use it to fly overhead power, gas lines, so on and so forth. Shout out to those two companies. They're outstanding companies and FLIR Partners. Hey, I know we've had a few questions already too about technical support. On handheld cameras up at the very top, US technical support and calibration. Remember, technical support is also FLIR Tools. So if you have FLIR Tools Plus, and if you want to have some fun, download a demo for FLIR Thermal Studio. This is a very, very in-depth thermal radiometric program. And I sat through a webinar with Jason Gagnon yesterday, and it was an outstanding webinar on all the different things we can do with it. Analyzing video, batch processing is something that's really a time saver for us in sUAS. We can apply the same color palette to all the images, and it will automatically make sure all the images have the same color palette, emissivity, T-reflect, et cetera, et cetera. Join us, because I think we're going to have more webinars. Matt's going to tell us about more webinars here for Thermal Studio too. Hey, don't forget to look us up on all the social media networks. YouTube is a great resource here. Remember, you go to YouTube and you get a lot of training on there. A lot of videos. Go to the FLIR channel. That's where you're going to see all the videos. Matt, I think we're pretty well wrapped up here, and looking forward to some questions if anyone has questions.
Oh, that's great, Bill. Thank you. No, and thank you for the plug on the social channels. Absolutely. Whether it's Facebook, Twitter, YouTube, LinkedIn, and Instagram. Best way to stay in touch with what's happening here at ITC. We're most responsive on those platforms. Certainly give us a like, give us a follow, and we will be, as I said here, in the next Oh, over the next several weeks, having more webinars and more topics. In fact, let me share that slide here right now for everybody. These are the handles that Bill was just talking about on Twitter, Facebook, YouTube, Instagram, and LinkedIn. And we'll have this recording posted up here probably sometime over the weekend, early next week at the latest. I'm going to actually try to get it up this afternoon. We'll see if time allows. So we'll have that recording there. And then other topics that are planned for next week that I'm actually working on right now. And if you have a second, actually, if you want to chat to us, send a little chat. What topics would you like to see here over the next several weeks? Whether it's with Bill on sUAS or whatever, with handheld thermography. We are definitely going to be putting together some other titles for you to watch. So there's that. I should mention, again, of course, the website infraredtraining.com for the US and Canada. And then for thermographers in Europe, the Middle East, and Africa, it's irtraining.eu. So with that, let me pause sharing for a second there. And I just want to go to the Q&A window to check if we've got any questions. I don't see any there, but I do see some in the chat window. And first question coming in was, are we going to offer sUAS Level 1 fully online? I can answer that, I guess. At this point, we don't have plans to do that. We are working on some other projects. At the moment, though, Bill, not any online certification for sUAS Level 1. Is that correct?
That's correct. Right now, we're not going to be, don't have any real plans for Level 1 online, Level 1 sUAS online. I know the Level 2, I've had a lot of questions and phone calls in my office. When are we going to put that out? That's going to be coming probably fourth quarter. We originally had it set for second and third quarter. Of course, we've had some delays in that because of the situation or the scene currently. But look for that probably in the third or fourth quarter. So I hope that answers that question.
I can mention that we are making plans here for later April into May. We don't have a concrete date yet, but we are working on a solution for a Level 1 certification that will be online, and that's something that is coming down the pike here. So just keep that in mind if you're looking for just basic training, basic certification. So that is coming up. Let's see here. I'm going to back up, Bill. Just a couple of questions here. This was an equipment question. I don't know if you know the answer, Bill. Can infrared cameras be carried on the DJI P3Ps?
You know, I don't have an answer to that question. I'm not familiar with the P3Ps. Steve, can you maybe chat me up? Or if you want to, william.schwan@FLIR.com.
I'll just type that into everyone here as we're on. So I'll type in william.schwan@FLIR.com. So I'll just send out Bill's email to everybody if you want to hit him up there with direct messages. Let's see. You know, while we're here, he was referring to the Phantom 3 Pro.
Got it.
So what about that then?
Yes, if you work with, there's several different distributors out there where IR cameras can be put on a Phantom 3 Pro. And, you know, of course, it may require that you also install a gimbal system. That gimbal system is, of course, to control the camera. So I would say check in with a distributor and get their opinion on what kind of camera would be best for your applications and how to apply that to your craft.
I had a question coming in from Tom about the pricing on the class and the possibility, I guess, of decreasing the cost of the course. I mean, the way the course is priced right now covers the cost that we obviously have involved for that. Really, the best way, Bill, that we typically say for people is if they want to reduce the cost of the class, the option of an on-site is something that we've done. Have you done any sUAS on-sites? That's something that we do offer.
Absolutely. The on-site class is a great option to reduce costs. We recently did one in Chandler, Arizona. And the advantage to that is that we save travel. So generally 13 to 15 people in a course. Of course, we fly during the course, so we can't quite get the numbers of 30 or 35 people because it's hard to manage the flight deck. But the on-site is a great way. And you might check out, drop me an email and I will link you to Alex Crucial, who will get you linked up and give you all the information on the on-site courses.
I'll type in Alex. I just type in Alex's email there as well. With the spelling on his last name. Good. Yeah, he's a great resource. Alex works in our office and he'll have all that information for you. And Bill's absolutely right. You do save the cost of travel, hotel, meals, all that stuff. We have a viewer here from Quebec today. I'm wondering about, I'm assuming Canadian training for sUAS. Are we offering any of that? Do you know about that, or what Paul's doing up in Canada, Bill?
You know, I know Paul Frisk, who's the ITC Canadian manager, is looking into it, and we've had some discussions about it, and he's looking into whether or not they'll provide a course in Canada. Of course, the Canadian standards are significantly different than the U.S. standards, but I know Paul is working on and looking into a course in Canada.
Got a question here from Nalter, just asking about the presentation being available. Absolutely. We will have this recording here. My plan is to have this up by this afternoon and then pushed out on the other social media channels, at least over the next few days. But for everyone who actually watched today, I'll have this on YouTube by later today, and then I should have everybody's email addresses, and we'll be able to push that out to you later this afternoon towards this evening. So you can watch it again, Nalter, whenever, or if you want to share that link with a friend, that's totally fine as well. Good. I just want any other questions before we wrap up? I think we've gotten to all of them. Make sure I didn't miss anybody. If you're still on, give it a second. Well, thank you, Kevin. I'm glad you enjoyed the presentation. We've got Bill's email there in the chat. I'll leave this open here for a little bit. Let me put my email there as well. If you have general questions about certification training or certification, let me type this in. You can also email me here, and then Alex's email is there as well. Bill, I think we'll call it a day here. I really appreciate it. Thank you very much.
Oh, thank you, Matt. And thanks again for everybody for joining us today. If you have any questions, drop me an email. All the best.
Great. And thanks for joining us, everyone, as well. We'll see you online again soon here with a future live web event. Until then, have a great weekend.